let's look at some basic integrals. So our assignment is going to be on page 422. The following problems will get us ready for a quiz. So we're going to use the graph to find the Riemann sum with 6 subintervals. Okay, so from here to here, what we're trying to do is to find the area, right? So we're trying to approximate the area between the x-axis and the curve. So up here we're going to get a positive area, and down here we're going to get a negative area. But when we add those up, we will have an approximation for the area. So if we break it into 1, 2, 3, 4, 5, 6 subintervals, what we're doing is we're saying that our step size delta x is just b minus a over n. So the entire interval is 6 minus 0 over the number of steps is 6. So each step is of size 1. So if each step is of size 1, first it wants us to do the left endpoint and the midpoints. So if we do the left endpoint, then I think that our triangles will look like so, or rectangles, excuse me. So what we're going to do for the first interval is we're going to use this left endpoint, and we're going to take f at the left endpoint, which is 0, and then we're going to multiply it. So we're going to have some x in the first subinterval times the delta x. So the x that we pick in the first subinterval is going to be 0, and our step size is 1. But from the picture, f at 0 looks to be a height of 2. So this is going to turn out to be 2. So 2 times 1, which is 2. Then we look at our second rectangle. Well, on the second subinterval, so our second subinterval is right here. It goes from 1 to 2. So I'm going to take some sample point in the second subinterval. So it's going to be my f at x sub 2 star times delta x is going to be the width of my rectangle. So the width of every rectangle is 1. The height in this case is here at 1. I plug in 1 into my function, and it looks like I get out a height of 3.5. So it seems like this y value is 3.5. I'm going to use that to approximate the height of my rectangle in the entire interval. And so I need to move that down, because what that is that is simply, notice what we've done, we've taken f at 1, and we've multiplied it by our height of 1. And then we just continue on like so. So let me bring these down here and continue on. So then we look in our third subinterval, and I take some x sub 3 star, some sampling point, in this case, inside of this 1, 2, 3 third subinterval. If I'm going to take the left endpoint, this time the left endpoint would be 2, is the left endpoint of this interval. So I'm going to take f at 2 times the height, times the width, and the width of each rectangle is 1. So it's going to be 1 times, well, at 2, it seems like here when I plug in 2, it seems like I get out a height of 1, 2, 3, 4. That looks like a height of 4 up there. So that's going to be the height of my rectangle on that interval. It's going to be 4. So I have 2 plus 3.5 plus 4 plus, and we keep on going, f at x sub 4 star delta x, f at x sub 5 star delta x, 1, 2, 3, 4, 5, 6. I need my f at x sub 6 star delta x. So if we go to the fourth subinterval and we sample any old point, well, they told us to do the left. So here is my 1, 2, 3, fourth subinterval. The fourth subinterval goes from 3 to 4. This would be the fourth subinterval. And on that subinterval, I use the left-hand endpoint. Well, the left-hand endpoint is just going to be 3. So I do f of 3 times my delta x of 1. And it looks like at 3, I get at a height of right here. How high is that? That is about 1/3. So that's about 2.3, right? I would say. So it's about 2.3 is the height times 1 gives me, for that rectangle, if the height is 2.3 and the width is 1, then the area of that rectangle is 2.3. So the area of that rectangle is 2.3.
How's it going?
Hey, how's it going?
Good.
What's up?
I heard.
Here, let me